This video is on precipitation reactions. And this should be review, hopefully, because precipitation reactions are the same as double replacement or double displacement reactions. So, quick reminder how these work. You have two compounds. Let's say we have like AX, for example, plus BY. All right, so what they're going to do is, if you remember, they're going to switch partners. So positive, negative, you're going to have ionic compounds, cation and anion. And when they recombine, they're going to be still a cation with an anion. So what I mean by that is, if A is positive, the only partner it can have outside of X would be Y. So you would get AY, and you would get BX. And remember, the cation goes first, and the anion goes second. So one last thing to remember is that these don't necessarily always react. So reaction occurs if one product is a solid, so that would be the precipitate, a gas, or water, like liquid water. If you don't see any of that, then we just write, if you remember, NR for no reaction. All right, so in order to do this and determine if your reaction occurred or not, means that you need to know the solubility rules. And these are on the back of your blue sheet. Now, there are some patterns in this. For example, if you look at your blue sheet, I would pause and get it right now if you don't have it. But there are some patterns in that things like nitrates are always aqueous. Alkali metals will make compounds that are typically solids aqueous. Things like silver, mercury, and lead will make compounds that are usually aqueous solids. So we're going to discuss some of these and look for some of these patterns in class. All right, so for now, let's just use our blue sheet and our the solubility rules, and let's just do a few examples. All right, so first one we have here, is, let's see, barium chloride and potassium sulfate. So I'm going to go through and I'm going to write their charges, because that's going to help me when I determine them switching places. So barium is +2, chlorine is -1, potassium is +1, sulfate's -2. If you needed more time, make sure you pause and practice this and look those charges up, whether it's on your pink sheet or your periodic table. So we're going to get barium is going to switch with potassium, because barium and sulfate can go together and potassium and chlorine can go together. It doesn't matter which new couple or compound you write first. So barium and sulfate with a +2 and a -2 will give me BaSO4. And then potassium and chlorine, +1 -1, will give me KCl. Now the 2's there make me balance it by putting a coefficient here. So the last part we need to do is we need to say, now that it's balanced, does it even react? So this is where we look at our blue sheet, our solubility rules. And I look up the anion. So I look up sulfate. Sulfate is in the aqueous side. And so it's aqueous unless your sulfate is with. There's some exceptions. It says strontium, barium, mercury, or lead. And I have barium. So that tells me it's not aqueous. It's solid. And then chlorides are all aqueous, and we don't have one of the exceptions. So this reaction does happen, and that's what we would get. We'd get this barium sulfate precipitate. All right, let's try another one. Potassium would be is +2, nitrates -1, sodium's +1, chlorine's -1. So here, we're going to get calcium combining with chlorine. So that's going to be CaCl2. And then we're going to get sodium with nitrate. So NaNO3. So when I look these up on the solubility chart, I look up chlorides, and it says it's aqueous unless it's with silver, mercury, or lead, which it is not. So this is aqueous. And then if I look up nitrates, they're always aqueous, no exceptions. So this is also aqueous. So this one does not react. So what we do is we just cross this out. We write NR for no reaction. All right, one more. We've got sodium is a +1, sulfide is a -2. We've got copper, in this case, is a +2. My nitrate is a -1. So sodium's going to go with nitrate, so NaNO3. And maybe you already realize it's nitrate. It's aqueous. I do this right away with nitrates. And then copper with sulfur would be CuS because we've got +2 and -2. So then I look up sulfides. They are solids, insoluble. We do not have an exception here. So this would be a solid. And then the only other thing we need to do is balance this, which would need a 2 as a coefficient here. So those are precipitation reactions, also known as double replacement. Hopefully this was review.